C++ classes. What is OOP? OOP stands for Object-Oriented Programming. Procedural programming is about writing procedures or functions that perform operations on the data, while object-oriented programming is about creating objects that contain both data and functions. Advantages over procedural programming. OOP is faster and easier to execute. OOP provides a clear structure for the programs. OOP helps to keep the C++ code dry, don't repeat yourself, and makes the code easier to maintain, modify, and debug. OOP makes it possible to create full reusable applications with less code and shorter development time. Tip: the don't repeat yourself dry principle is about reducing the repetition of code. You should extract out the codes that are common for the application and place them at a single place and reuse them instead of repeating it. C++. What are classes and objects? Classes and objects are the two main aspects of object-oriented programming. Look at the following illustration to see the difference between class and objects. So, a class is a template for objects, and an object is an instance of a class. When the individual objects are created, they inherit all the variables and functions from the class. Example: create a program that use class and objects. Example explained. TheclaSkyard is used to create a class CalAdMe class. ThePublic is annexes specifier, which specifies that members, attributes, and methods of the class are accessible from outside the class. Inside the class, there is an integer variable and a string variable string. When variables are declared within a class, they are called attributes. At last, in the class definition with a semicolon, create an object. In C++, an object is created from a class. We have already created the class named Michaelis, so now we can use this to create objects. To create an object of me class, specify the class name, followed by the object name. To access the class attributes menu string, use the dot syntax on the object. Note: you can create multiple objects of one class. Class methods. Methods are functions that belongs to the class. There are two ways to define functions that belongs to a class: inside class definition, outside class definition. In the following example, we define a function inside the class, and we name it method. Note: you access methods just like you access attributes, by creating an object of the class and using the dot syntax. Inside class example. The method or function defined inside the class. To define a function outside the class definition, you have to declare it inside the class, and then define it outside of the class. This is done by specifying the name of the class, followed the scope resolution operator, followed by the name of the function. Outside class example. Method or function definition outside the class. You can also add parameters. The parameters is inside of open and close parenthesis. Constructors. A constructor in C++ is a special method that is automatically called when an object of a class is created. To create a constructor, use the same name as the class, followed by parentheses. The constructor. Note: the constructor has the same name as the class, it is always public, and it does not have any return value. Constructor parameters. Constructors can also take parameters just like regular functions, which can be useful for setting initial values for attributes. The following class have brand, model, year, attributes, and a constructor with different parameters. Inside the constructor, we set the attributes equal to the constructor parameters brand equals x, etc. When we call the constructor by creating an object of the class, we pass parameters to the constructor, which will set the value of the corresponding attributes to the same. Just like functions, constructors can also be defined outside the class. First, declare the constructor inside the class, and then define it outside of the class by specifying the name of the class, followed by the scope resolution operator, followed by the name of the constructor, which is the same as the class. Access specifiers. By now, you are quite familiar with the public keyword that appears in all of our class. The public keyword is annexes specifier. Access specifiers define how the members' attributes and methods of a class can be accessed. In the example above. However, what if we want members to be private and hidden from the outside world? In C++, there are three access specifiers. Public members are accessible from outside the class. Private members cannot be accessed or viewed from outside the class. Protected members cannot be accessed from outside the class, however, they can be accessed in inherited classes. In the following example, we demonstrate the differences between publicants. If you try to access a private member, an error occurs. Because Y is private. No, it is possible to access private members of a class using a public method inside the same class. See the next chapter encapsulation on how to do this. Tip: it is considered good practice to declare your class attributes as private as often as you can. This will reduce the possibility of yourself or others to mess up the code. This is also the main ingredient of the encapsulation tech. Note: by default, all members of a class are reprivative. You don't specify an access specifier. Encapsulation. The meaning of encapsulation is to make sure that sensitive data is hidden from users. To achieve this, you must declare class variables or attributes as private, cannot be accessed from outside the class. If you want others to read or modify the value of a private member, you can provide public get incidenthism. Access private members. To access a private attribute, use public get and set methods. Example explained. Thesalary attribute is private, which have restricted access. The public setSalary method takes a parameter s and assigns it to Thesalary attribute salary equals s. The public getSalary method returns the value of the private Thesalary. Inside main, we create an object of the employee class. Now we can use the setSalary method to set the value of the private attribute to 50000. Then we call the getSalary method on the object to return the value. Why encapsulation? It is considered good practice to declare your class attributes as private as often as you can. Encapsulation ensures better control of your data, because you or others can change one part of the code without affecting other parts. Increased security of data. Inheritance. In C++, it is possible to inherit attributes and methods from one class to another. We group the inheritance concept into two categories. Derived class child, the class that inherits from another class. Base class parent, the class being inherited from. To inherit from class, use the symbol. In the example below, the car class child inherits the attributes and methods from the vehicle class parent. Why and when to use inheritance? It is useful for code reusability. Reuse attributes and methods of an existing class when you create a new class. Multi-level inheritance. A class can also be derived from one class, which is already derived from another class. In the following example, my grandchild is derived from class Mikhail, which is derived from E class. Multiple inheritance. A class can also be derived from more than one base class, using a comma-separated list. Access specifiers. You learned from Thesis Specifierschapter that there are 3 specifiers available in C++. Until now, we have only used public members of a class are accessible from outside the class and private members can only be accessed within the class. The third specifier, protected, is similar to private, but it can also be accessed in the inherited class. Polymorphism. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. Like we specified in the previous chapter, inheritance lets us inherit attributes and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. For example, think of a base class CalAnimal that has a method CalAnimalSend. Derived classes of animals could be pigs, cats, dogs, birds, and they also have their own implementation of an animal sound, the pig oinks and the cat meows, etc. Remember from the inheritance chapter that we use the symbol to inherit from a class. Now we can create a pindadog testblock and override the animal sound method. Why and when to use inheritance and polymorphism? It is useful for code reusability. Reuse attributes and methods of an existing class when you create a new class. C++ files. TheFStreamLibrary allows us to work with files,